Page 2 of functions. Decide whether these relationships are functions. Explain your decision in the cases in which they are not functions. Remember that capital R is the set of real numbers. Okay. The first set is the set of real numbers, and the second set is the set of real numbers, and the relationship is defined by the equation y equals 3x plus 1. Okay, so basically here, every single x maps to one value of y. So that's fine. This is a function. What about B? The first set is the real numbers, and the second set is real numbers, and the relationship is defined by the equation y equals x squared. Okay, so in this one here, all values of x map to some y. Okay, you can put any x in here. So that's a function. C. The first set is the set of real numbers, and the second set is a set of real numbers, and the relationship is defined by the equation y equals square root of x. Okay, remember that for x here, you can only put positive numbers because you cannot have a square root of a negative number. Okay, so that means there are some values in the first set which you cannot get a y for. It doesn't work in this equation. So it's not a function because negative values of x have no y. Okay? What about D? The first set is the set A where x is greater than or equal to 0 and x is a real number. And the second set is a set of real numbers, and the relationship is defined by the equation y equals square root of x. So it's the same function, or the same equation as before, but now they've reduced the first set to be just positive real numbers. So now we're okay, because every single positive number can be put in this equation, and we get a y out. So this is a function. Okay. Next one. So this is giving us some terms here. The first set, they always say the first set, the first set. Another name for the first set is called the domain of the function, which is like the set of numbers that can be put as an input to the function or x values, okay? Also called the independent variable, like in science projects. For each value of x input, there is one and only one output. This value is called the image of x. The set of all of the images, all of the outputs, is called the range of the function. Okay, so some words, some terms for y, the output value, are output, image of x, range of a function, also dependent variable. Okay, let's look at a problem. For each of the functions in A through D, copy and complete the table, put a big X in any cells that cannot be completed. Write down the domain, decide if y is equal to 0 is in the range of the function, justify your decision. Okay, so for A, y equals 2x. We're going to try to fill in the table for y equals 2x. So let's start with 0, that's an easy one. Y equals 2 times 0. Okay. What about for 1? Y equals 2 times 1. What about for this one? Y equals 2 times 3.5 is 7. What about for this one? Y equals 2 times negative 1/2, that would give me negative 1. And then what about for this one here? What do I double to get 12? It would be 6. Okay. Now I'm going to write down the domain. So the domain of this function is all real numbers. Now number 3. Decide if y is equal to 0 is in the range of the function, justify your decision. Yeah, y equals 0 is in the range of the function. It's right there. Okay. So, because when x equals 0, y equals 0. Okay, so that's the reason why y 0 is in the range of the function. What about b? Y equals x squared plus 1. Okay, so we'll start with 0. If we put 0 in there, we get 0 squared plus 1 is 1. What about 2? 2 squared is 4, plus 1 is 5. What about negative 3? Negative 3 squared is 9, plus 1 is 10. What about 1/4? 1/4 squared is 1/16 plus 1 would be 17/16. Yes. Okay. What about 5? What's the value of x that would give 5? Let's see, to get 5, x squared would have to be 4, so I could put x equals 2, I could put x equals -2. Either one of those would give me a y equals 5. Okay. C. Y equals x plus 1 is the function. If I put 0 in, then I'm going to get y is 1 over 1, which is 1. If I put -1 in, oh, well, look, negative x can't be -1, so we're going to put a big X here. Oh, by the way, we forgot to answer in B. We're supposed to say, write down the domain. The domain for this is going to be any real number. And then we're supposed to say whether y equals 0 is in the range of the function. Is there any way we can get y equals 0? Is there some x we could put in there and get y equals 0? And no, we can't. So y equals 0, not in domain. Okay? Because no real solution for 0 equals x squared plus 1 or x squared equals -1. Okay? All right, let's get back to C. So if we put 1/2 in there, we get 1 over 1.5, which is 2/3. If we put 3 in there, we get 1 over 4. And if we put -2 in there, we get 1 over -1, which is -1. Okay? And then what about 1/6? How do we get 1/6 out of here? If we put x equals 5 in there, then we would get 1/6, right? Now what about the domain? What is the domain of this function? It would be x is all real numbers except x is not equal to 1. And they specified that right here. Okay? What's the other thing they're going to ask? Y equals 0. Can y ever equal 0? Let's see. 0 equals 1 over x plus 1. No, to make that 0, x would have to be, an infinitely huge number, which is not a solution. Okay? So y equals 0, not in range. Okay? Because no solution for 0 equals 1 over x plus 1. Okay? What about D? Y equals the square root of x. Okay, where x is greater than or equal to 0. So if you put 0 in for x, then you get 0 out for y. If you put -3 in for x, that's illegal. Square root of -3 doesn't exist. If you put 1/4 in there, the square root of 1/4 is 1/2. How about 1 is the output? What do you put in for the input? 1. What if you put 9 in for the input? What do you get for the output? 3. How do you get 10 for the output? What do you put in? 100, right? Okay, now what about the domain? The domain is x is all real numbers, x is greater than or equal to 0, right? Because they already said x has to be greater than or equal to 0 here. And then is y equals 0 in the domain? Yes, it's in the domain when x equals 0, y equals 0. So y equals 0 in domain. Okay? Number 2. Decide whether each statement is true or false. Justify each of your decisions. Y equals 0 is an element of the range of the function y equals 2 over x. Is there a solution to this? Y equals 2 over x. No, x would have to be like infinity. Okay, so false. No solution for 0 equals 2 divided by x. Okay, that was for A. What about B? The equation y equals x squared cannot take the value -1. That's true. That's true because x squared is always positive. C, the equation y equals x squared plus 3 cannot take the value of 2. That's true. X squared plus 3 is always greater than or equal to 3. D, for the function y equals x squared minus 1, there are two values of x when y equals 3. That's true, right? Because we have this solution. 3 equals x squared minus 1. That means x squared equals 4, which means x equals plus or minus 2. Okay? E. For the function y equals x divided by 3 minus 1, the image of x equals -3 is -2. For the function y equals x divided by 3 minus 1, the image of x equals -3 is -2. Okay, so let's test that out. So if we have, let's put x equals -3 in for that function. So we'll have -3 divided by 3 minus 1. And what does that give us? Y equals -1 minus 1, -2. Okay, so yeah, that worked. So it's true. F, for the function y equals 2 times the quantity -x plus 1, the image of x equals -1 is y equals 0. So we have 0 equals 2 times negative of -1 plus 1. Negative of -1 is just 1, right? So negative of -1 gives us just 1. So we have 1 plus 1, which is 2, times 2, which is 4. So no, that's not true. Okay, they said that y was going to be 0. Actually, y is 4. Okay, last question, 4C. Draw the graph of the function y equals 2x minus 4. Now, we're used to doing problems like this, right? So we're going to put y-intercept -4, and then we're going to put a slope of 2. So that is 2 divided by 1, 2 divided by 1, 2 divided by 1, okay? That's the slope, okay? Draw the graph. Write down the coordinates of the point where the graph of this function meets the x-axis and the y-axis. Okay, we know it meets the y-axis at -4 because it's in gradient intercept form, and there's the y-intercept right there. What about the x-axis? We can see from our graph that it intersects the x-axis at y equals 2, or x equals 2. Put 2 there. Decide whether the point A, which is 250, 490, lies on the graph of this function. Justify your decision. Okay, so since we know the equation of the line, we may graph it on the calculator, and that's the first thing we're going to want to do. So we'll put in the equation. It's 2x minus 4. 2x minus 4. Hello, calculator. 2x minus 4. Okay. Okay, so there's two ways to do this. I'm giving you a hint here. You can do second table or graph trace. Here's the graph. It says, what's the y value? Is the y value 490 when x equals 250? Let's test that out. We're going to do a trace, and we're going to put in the value 250. Ooh, unfortunately it gives me an error because 250 is way off the screen. So let's make it so the 250 is on the screen. We'll do a window, and then we'll make the x max like 300, and then 250 will be on the screen. The other thing we're going to have to do is we're going to have to make it so that the zoom is zoom fit, because if we go out to x equals 250, then y is going to be huge. We want to make sure it's still on the screen, so we do zoom fit. After you adjust the x value, you should always do a zoom fit. Oh, now it's going to graph. And then after it graphs, we're going to search for trace x equals 250. So we'll go trace 250. And it gives us that y equals 496. Ooh, it's not 490, it's 496. Okay. We could have also, done this with algebra. We could have said y equals 2 times 250 minus 4. So that would be equal to 500 minus 4, which is equal to 496. Okay? All right. The other way you could do it is you could use the table. You could do second table. And then you can see that there are x values and y values. And if we go down to 250, then eventually we're going to find the y value. Now 250 is way down there. So one thing we could do to help us is we could count by tens. So we could go to 10 and then we'll go plus 10. And then we'll jump down by tens. And then we just go down to 250 much quicker. Almost there. Almost there. There we go. 250, 496. Do you see? Again with the 496. So there's several ways to figure out that y equals 496 and not 490. D. The point B, negative 3 comma y, lies on the graph of this function. Find the value of y. Okay. So there's a couple ways to do this. One is using the graph. If we use the graph, let's adjust the graph so that we can see x equals negative 3. We're going to move the graph so that it's about here. Okay, and then now we're going to continue the line of the graph, and it'll go down 2 more here, and it'll go down 2 more here, and then it's about there, and then it'll go 2 more here, and it's right there. Okay. So we could kind of figure out with graphing, we could say, oh, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, negative 9, negative 10. So it's negative 10. So the value for y is negative 10 we found by graphing. Now we can also find it with the table. So let's go back to 0. We're going back to x equals 0, and then we're going to adjust the step size one more time. You should always adjust the step size when the cursor is on 0, otherwise you can get some weird stuff here. We'll make the step size 1 again. Okay, and then we'll go back to x equals negative 3. And what's y? It's negative 10. Okay, what's another way we could do it? We could do it with the graph. So we'll do graph, and then we could do trace. We do trace negative 3 and y equals negative 10 again. Okay, so 3 different ways we found that y equals negative 10. And that's the end of page 2.